Welcome back to the discussion on pillow drawing image library. In this video segment, we will be discussing more about the creative aspects. The submodule under pillow called image draw allows us to put in new content on top of the image or on top of parts of the image, right? Or whatever it is. So, or even over no image. We don't really have to have an image to begin with. We can create a blank image as a canvas and then draw on it, write on it, and do something creative out of it. Okay. Now, when I say image, of course, as I mentioned at the start of the whole series of video segments here, that image can be also sourced from the graphs and charts that we produce using pandas and seaborn libraries, right? So we can annotate, we can now highlight, we can circle out, we can focus in, and we can do a lot of interesting things, starting from the charts that are generated by pandas and seaborn. So to begin these creative aspects, annotative aspects, definitely import this submodule under the pillow library called image draw. Image draw. So once you have imported it, we can start to use the dot draw. Now, one has to have the right concept of this draw, because different Windows systems, and I'm not just referring to Microsoft Windows. For example, Apple's Windows, its ability, its style of managing all the window objects and all that. Different Windows systems tend to have different ways of looking at how drawing should be done. So fortunately, in this image draw, it is quite straightforward. The idea is there is, of course, a starting point. Where do you want to draw on? Which image do you want to draw on, right? So this image, this source image, image 1. Now remember, even though I illustrated with opening an existing JPEG file, we are not restricted to that. We can always create image 1 equals to image.new, right? A blank canvas of certain color, like white. Or we can create an image by loading in from a saved pandas plot or saved seaborn graph, so we can always start from anywhere we like. So this image draw.draw, what it does is it creates a drawable version of image 1. A drawable version of image 1. Think of it as this is the image 1 drawing, but you're not supposed to touch it. It's free only, right? So you're not supposed to touch it. However, through a special device called drawable, you can draw on this drawable, and the drawable will kind of update the image 1 behind the scene. That's why we need to link image 1 to this new object called drawable. So whatever you draw onto the drawable, you can imagine it being committed to the image 1. It will link through. Okay. Now, of course, we need the drawable because remember, image 1 is just an image. It has no methods, no functions, no means of allowing you to say image 1 dot draw line. I mean, the pillow library people could have, reconfigured the functions and put it that way, but they didn't. So because for fast image performance kind of processing, where a particular program may not be trying to draw anything, then all the whole lot of drawing functions are not very useful. So there's some balance of efficiency here, where, for example, now we're very interested in drawing, then we import the image draw, and then do we want to create a drawable version of image 1? So actually that's quite a good trade-off, right? So the overall design is very clean and at the same time efficient. So once we have obtained a drawable version, maybe I should put it as drawable image 1, right? Because whatever we touch onto drawable only modifies image 1. So when we say drawable.line, 50/50, which is because this is probably 1400 pixels or whatnot. So 50/50 is almost here, ending at 150, 250. So 150, 250. So it's longer than its wide, than its width, right? So in that case, this is the line. And we fill it with some sort of a reddish line, 250, very red. 255 is maximum. half green and a bit of a blue. So remember 255, 255, 255 will be white. So it's sort of pale red. That's okay. And a width of 20 pixels. And that's a thick line because this is 1004, so 20 is more visible. But if you put 1 pixel, you could probably see it if you enlarge it, but at this scale, it's probably hard to see. So we put 20 pixels. Then we look at the size, all right, and what we do is we halve the size minus 200. So half the size minus 200, it'll be here. It'll be here. We look at the height, half the height and minus 200. So again, it's here. So half the size minus 200, half the height minus 200. So it is here. And then half the width plus 200, half the height plus 200. So essentially we are saying from here to here, from top left of this ellipse, but because the long radius and the short radius are the same, so it becomes a circle. Top left to the bottom right, can you draw an ellipse? So this is what we mean. So draw an ellipse within the top left, comma, bottom right. Don't fill it. That's why we see a hollow in the middle. But if you put it as green or blue, then it will be a disc, right? The outline will be this color. So heavy emphasis on green, little bit of red, little bit of blue. So it's a nice looking lime green and a width of 15. We probably can't see whether this green border is thinner than the red line, but yeah, we know that this is 20 pixel width and this is 15 pixel. Now notice the line here is slanted. Earlier on when we talked about using dot paste, we could trick it to draw vertical line and horizontal line of any thickness, but only restricted to vertical and horizontal because of efficiency for dot paste. Here, using line, we can draw anything we like and it's optimized. Okay, so just feel free to. We can also draw rectangle, starting 20, 20, ending whatever is the width minus 20, right? So we are leaving the same width borders, and whatever is the height minus 20, and that is giving us the same bottom width as the top, bottom border and as the top border. And filling it with bluish, right? Heavy emphasis on blue, and width of 10. So again, not sure if you can see the blue width is thinner than the green width, but between the blue and the red, definitely we see a big deal of difference in terms of the width size. Yeah. So of course, it's not unexpected. Now there are other functions to draw other primitives like drawing polygons, curves, arcs, that means semicircles. You can and a cloud of points efficiently. Definitely look up the image draw documentation for all those. Once you get started and manage to get a few of these going, the rest are the same, right? The main concept is top left, bottom right, and width comes before height, x comes before y. Now, on the second part of this slide, we want to also quickly introduce you to a very, very fun aspect, and that is annotating. How do you draw text? How do you draw text? To draw text, it is also under drawable. So you need to import image draw. In addition, it is a little bit primitive because you do have to import and manage your own image font. I do hope this part can be a little bit more enhanced so that there is certain uh, default fonts available, or else it will automatically look up the system fonts or whatever. You have to now create a font. A font equals to image font dot true type and specify times. Mine will be Times Roman here. Times Roman dot true type font TTF and of size 80. This size 80 is in the same sense as when you open up Microsoft Word and it defaults to a point size of 12, right? So this 80 is indeed many, many times larger than the point 12. It's true. So it's comparable. And reason why it's 80 and it's still looking just nice is because my picture is actually really large. It's probably 1400 by width and then 1000 plus by height. So 80 is just right, and it seems just right. So if you put 12, no, the text is not going to be visible. Okay, so the size of the font and true type fonts are nice because when you size it large, you don't see pixelation. So this is why we use TrueType fonts. Then all we need to do is to say draw where and draw with what text and what color. So drawable dot text, but on which image? And yeah, we don't have to ask because drawable is always linked to image one. It's always committed to image one. So at this place, 300 comma 1000, right? So pretty deep down, but a bit starting off. Uh, what is the text? Followed by the text. This is great. What color do you want? So filled with deep red, deep green, so they add up to yellow, and a bit of blue to give it more color, so yellowish. And what font do you want? And that is our font that is being created, our font object here. Okay, so fortunately you don't really have to delete the font when you don't want, just exit the program will do, right? So unlike C++ programming, you have to mentally actively free up the font because it's pretty memory consuming. Then we show it and we get this pretty diagram, pretty nicely uh, annotated diagram. So imagine that this is your diagram and you want to create some sort of a sharpshooter kind of drawing. You can always draw line and circle and all that, right? And if you want to automatically box out human objects, you can use some sort of feature detection. If you find a human figure, maybe it's round and a neck and a body, then circle it or box it, and then you can do automatic boxing and then annotate it. This is there are two people identified. Okay, so imagine all the possibilities, right? So I leave you at your dreamland to think about what you can do. This is really very amazing stuff that really opens up our creative box, right? So definitely let that go and try to play around with it and see what excellent images you can come up with.